Okay, hello and welcome to this Muk3D formation tutorial. My name's Sam Rivet and I'm a solutions engineer here at Muk3D. Before I begin, just a little bit about myself. So I'm a professional mining engineer by trade. I spent the first 6 years of my career really cutting my teeth at the oil sands sites up north here in Canada. Following that, I was a consulting mining engineer and then a project engineer in highway construction for a few years. Following that, I became a solutions engineer for a Canadian-based satellite surveying company before joining Muk earlier this year. So really, I just wanted to, put on a webinar today to really display some tools within formation that I think are really practical, really powerful as it relates to Earthworks planning. So really, when I use software, I'm looking at it through the lens of, what tools could I have used, would I use in the projects I was involved in. So within the context of a fictional road construction project today, we're going to take a look at some of, my favorite tools that I've encountered since I've started. Okay, so we're gonna cover a lot of content today. I'm gonna try to pack as much as I can into an hour. If I gloss over something, I'm going really quickly. Don't worry. Everything we cover today is documented very comprehensively in these three publications. We're gonna release these after the webinar. You can download them in PDF format. You're also gonna get access to all the electronic files that we're using today, so you can, work with the data, with the instruction manuals open, and really, dive into whatever tool interests you the most. Okay, so we're going to begin by talking about locating, downloading, and georeferencing publicly available topography and satellite imagery to utilize in our planning. So we haven't purchased any survey data. We haven't purchased any imagery for the purpose of this webinar. So we're really going to take advantage of publicly available data sources. I know, for whatever reason in my career, whether it be logistics or budgetary, I'm often waiting for this information to come in to start my planning. So really, there's some great tools embedded within formation to kind of circumvent those problems so you can get that information in quicker and really start your planning. Okay, from there, we're going to use that imagery. We're going to use that topographic surface data to establish three different road alignments. And then, we're going to go from conceptual ideas of, where roads could be to, developing quantities, cut fill quantities, stripping quantities. So we can start to quantitatively compare these against each other and, make decisions based on real values. Okay, after that, surface water management. So I think it's going to be very difficult to execute, any type of large scale earthworks project without having at some level to manage the surface water. So we're going to look at within formation, how do we estimate the flow of water, the amount of water, and then, layout, design, put in some ditching and some water storage areas to really manage that surface water that can become a problem. Okay, following that, we're going to take a look at laying out and designing stockpiles. Stockpiles that are specifically located in the footprint that we want to contain a specific volume, and how formation really has the tools to do that very quickly. And then in the end, take a look at incorporating more custom, more complex road designs. Often you're working with a very straightforward design, flat running surface, a couple side slopes. Okay, what happens when there's a lot more granularity, a lot more detail, a lot more material types? How do you get that level of complexity into your planning from the beginning so you have full continuity throughout the process? Okay, so in terms of this fictional road construction project, just have some general specifications here to kind of anchor things. So firstly, when we're building above grade, and you can see kind of a road design and cross section here, you're going to want at least 3 meters of fill minimum. If we're building up above the grade, we can come up at 6:1 in terms of the side slope, and there's a 30-meter wide running surface. Okay, here you see what happens if we're cutting below grade. Now, we can cut down at 3:1, so a little different than filling. We can go in a little steeper. Once again, 30-meter wide running surface, and no minimum thickness in terms of excavation depth. Okay, here we see kind of a mock-up plan view of the road. This orange dashed line here, this would be the center line. So I want to establish a realistic, engineering condition here, which would be you have a limited amount of space to work in. You have a limited amount of space to build your road in, where you can stockpile material, where you can dig sumps. So I'm going to say 250 meters on either side of this center line. So 500 meters total is the jurisdiction in which you can construct. Okay, also along this center line here, there's going to be longitudinal maximums in terms of the slope depending on the alignment. So the first alignment is going to have a max slope of 8%, second one 10.5%, third one 11%. And this is just to make sure that it, the road isn't too steep, it's safe to drive on. And once again, would be something that you would find in real life. As well, this is going to be a balanced cut fill project, right? So the amount of volume that we excavate to build a road, we want it to equal within 1% the amount that we need to fill. And this is important in a real life application. You don't want to be in a situation where you're at the end of the project and let's say you have a big volume deficit. Now you have to start borrowing a separate area for more dirt, or let's say you have a big excess of material at the end and you have to get rid of 150,000 cubes and you're not sure where to put it. That can get very expensive. So you're going to need a balanced cut fill, max slope, and construct everything within a specific right of way. Okay, so to begin, let's discuss sourcing satellite imagery. So we're not going to begin in Formation. We're actually going to begin in Google Earth here. Okay, so let's say you don't have satellite imagery. A good source of free satellite imagery is Google Earth Pro. It might not have 10, 20, 50 centimeters in resolution, but there's an abundance of data and it really covers the entire globe. Okay, so there's great functionality built within Muk to import data. All you have to do is define your area. So I kind of selected this area in northern Utah for no other reason than it seemed interesting from a topographic point of view. Okay, so all you have to do is, once you have your area defined, just place a couple pins. Just make sure you name these pins based on their coordinates, and then just save this image with the pins present, and then save it again with no layers on, no terrain checked, everything blank, in the exact same area. Okay, once you've done that, you can go in here, and by using the imagery, georeference Google Earth image tool, you upload your reference image with the pins, your image without the pins, and then you can see here, you can import a 2D georeference tile of that imagery. Okay, we don't have survey data yet, so everything's just flat, set to a 0 elevation, but it is georeferenced in X and Y based on that pin data, which had the coordinates on them. Okay, so we want to pair this with some topographic surface data. Okay, for that, I'd go to the USGS Earth Explorer website. First source of survey data we're gonna download is SRTM data. So the USGS website is operated by the US government. It has a collection of all the satellite data archive that they collected over the years that they're willing to share with you. Obviously, because this is a government website, it is down for maintenance right now. However, I did save some screenshots, and this is actually taken from the PDF documents. Okay, so it's a map-based interactive viewer, so you could just zoom like Google Earth Pro, zoom in on the area you want. Pick your data set. In this case, I'm going digital elevation, SRTM 1 arc second global, and you can see here you're going to get a result. It's actually a very large footprint of survey data. It's probably about 5,000 square kilometers. This data is pretty sparse, this SRTM data, in terms of its point spacing, but it comes in huge pieces. And then you can import that raster directly into Formation, and it's going to give you some information. It's going to give you the source projection, point counts, and then you can immediately have a grid available to you. And you can see that here. So you can see our imagery here, and then that SRTM data that we downloaded. And you can see it's fairly massive. But just something to note, this process probably takes minutes to do, and you have a massive amount of survey data, easily viewable. I really like how the software just makes it very easy to visualize it, to rotate it. You can set the vertical exaggerations here if you'd like to a custom value or preset values. Also, something that I like is using this HSV shading to color code my surface by elevation, so I can just drag and drop it from the DB viewer onto my surface. Also, at this stage, I should note I'm using a beta version of the next release of Muk3DFormation. So if your software looks a little different, it's because you haven't gotten this version yet. It's going to be released at some point this year. Okay, so I'm just applying this shading to this very large topographic surface. And you can see here, nothing revolutionary, but just color coding the topographic surface based on elevation really makes, areas stand out and is going to help us make decisions, especially when we're trying to come up with an alignment or pick a spot to place an excavation. Okay, so what I would do here, because I have way too much survey data, more than I need, I'm going to extract a smaller piece here. And I'm also going to increase the point density on my surface. So right now, if I pick this SRTM surface, I can see here I have a grid spacing of 27.4 meters, meaning there's a data point every 27.4 meters, which is a little sparse. If you're designing something that's quite narrow, 5, 10, 15 meters, you want a grid spacing that's going to align with that. So I'm gonna use the grid tool. I'm gonna go grid, create, extract from existing grid. Then I'm gonna define a smaller piece of the grid that I want. Then I'm gonna go to data import, raster, resample the raster. I'm gonna take my smaller grid now, and I'm gonna change the target spacing to about 10 meters. And that's gonna result in having, just a smaller piece of survey. Now, because my imagery is larger than my topographic surface, I can just take my satellite imagery and then just place it directly onto my topographic surface. And you can see here now, for no cost, I have topographic surface data with satellite imagery in 3D. And you can start to visualize things. It doesn't seem like a big deal, but I want to build a road alignment. I want to avoid this urban area. I want to avoid this, what seems to me like some sort of drainage ditch that's pre-existing. So you're just getting a lot of information in terms of the elevation of things and the location of things. Okay, let's say you want something a little better than SRTM data. It is probably going to have 3 meter in vertical accuracy, or within 3 meters in vertical accuracy. There isn't that much data in terms of the point spacing. Every 27 meters is a little sparse. Okay, so the USGS also has another section to their website, the TNM downloader. All these links are provided in the PDF documents, by the way. So once again, you can just go to your area here. Another map-based search function. Okay, I can see that this is my area. Make a polygon. Double click when you're done, and then come down here and you can see this is what I'm looking for here, LiDAR data. So this is super high quality survey data, 5 to 10 centimeters in accuracy, probably bare ground surface, penetration through the trees. So this is, expensive survey data if you're trying to, gather it new. So as long as you're not too concerned about the data on your data, this is a good source for anything within the United States. If you're looking for outside of the United States, SRTM data will be available, but you'll probably need to source it from a separate website. So you can see here, getting a lot of results, and you can just download these LAZ files directly. And then once again, you can bring them in. You can just save them directly into your formation folder, and then just, bring in these point cloud files. So you can't really see what they are right now because we haven't triangulated them yet, but they're coming in 1 square kilometer pieces. So if you're going to try to cover a huge area, it is going to take some time. For example, the SRTM data came in like a 5,000 square kilometer chunk. This is coming in 1 square kilometers, but there's a lot more data here. So, and then you can just take these directly and build a surface out of them. Just go to surface, create surface from point cloud. And as you can see here, I did that for a number of tiles and recreated the entire area with that LiDAR data. And you can even see, in plan view from here, a little bit of a difference in the quality of this versus the SRTM data. But yeah, once again, so this is a lot of data, tons of points, LiDAR data, very easy to import. This was very quick and added no cost. And you can really just start to visualize and rotate the data in a very easy to use fashion. Okay. So that's just something I wanted to include. I know I've spent a lot of time in my career waiting for updated survey, waiting for imagery. So, let's say you have a lot of sites, you're considering a lot of different locations, you don't have budget approved yet. This can be a great way to just get that data in, and then you can start planning in, in a 3-dimensional environment. Okay, so let's get into it. So I'm just going to open my smaller SRTM surface again. And, I'm going to use the information I'm getting from the picture. I'm going to use the information I'm getting from the topography. We're just going to lay out 3 different alignments. Okay, my first one, I'm just going to come straight through here. And I'm trying to target this lower area in the mountains. Obviously, there is an existing road here, but, that wouldn't be any fun. So, as a condition, I'm just going to try to cross these mountains with 3 different alignments. Okay, I'm going to take another alignment. I'm going to go east this time. Okay, so this one's going to have an 8% slope, point to point, longitudinally. Max, this one's going to have a 10.5% one. Then I'm going to go left here, and this one's going to have an 11% one. Just trying to, handicap the alignments that I feel are going to be more heavy in volume. Okay, so let's focus on alignment 1. Okay, so the first thing I do is I'm going to create my corridor here, and you can see that in black. I think it's always good to start planning and establishing your corridor. I know I've been involved in projects where that's something that we didn't take into account closely enough, and then you get into situations where you just don't have the real estate you think you're going to have, and that can start costing a lot of money. As well, before you construct this road, you're going to have to strip it. So I'm not exactly sure the composition of this terrain, but I'm going to assume there's a level of topsoil that I'm going to need to remove. And you want to work on a topographic surface that's going to reflect reality. So the reality is, excuse me, the reality is you're going to have to strip any construction area. So within the footprint of your road, you're going to have to remove that topsoil and stockpile it and use it later. So what I would recommend, because we don't know where our road is yet, is you create a box or a polygon out of your corridor, and then you drop your topographic surface by the amount of topsoil you expect. So in this case, I'm going to say 30 centimeters of topsoil. So I'm going to go to grid. I'm going to go to grid, modify grid elevation with boundary. And then I'm just going to drop this by 30 cents everywhere within my corridor. Then I'm going to design my road, establish the exact footprint of where my road would be in a topsoil stripped environment. And then that's going to let you know exactly where those toes are going to be. You're going to send that information to your surveys. We're going to stake that. Operations is going to go out there and strip exactly within that footprint to minimize the amount of topsoil you're producing. But once again, you don't know where your road's going to be in advance. So just strip everything, design your road, establish where your road's going to be, and then you can restart and then just strip in those areas. Okay. All right. So I have my alignment. I have my right of way. So now I want to build a road. Okay, so one of the conditions that I set out at the beginning was I want 3 meters of fill in situations where I'm building above grade. So I'm going to take my polyline and I'm going to drape it onto my surface. Now, what I'm really trying to do here is I want to densify the polyline with a lot of points. So right now, if I look at my polyline and I look at the property window, it has 32 points because I've done this in reverse. But so I want to densify this data. I want more points on there, and I want everything to sit specifically where I want to, 3 meters above topography. Okay, so I'm going to drape the line on the surface. I'm not going to put an offset yet. It's going to ask me what surface I want. I'm going to select my grid. Then I'm going to drape my line. So this function is extracting all that data from the surface, and it's going to imbue it into my line. So right now my line has, if I look at the properties again, 1,793 points. So that's way too many to work with. So I'm going to go here. I'm going to edit it. I'm going to clean the line. All right. I'm going to clean the line, and I'm going to remove duplicate points. So every 250 meters, I'm going to have a data point now. I'm just going to pick my line again, and that's going to get me back to that 30-ish range. You can see now I have 33 points. Okay, so now I have a line that's draped on my surface with 33 points. So I want it 3 meters above my topography and fill situations. So I'm going to go back here, polyline, drape points on surface. Now this function is going to also drape it on the surface, but it's not going to densify. It's not going to add any points. And this time I'm going to drape it with a 3 meter offset. So now my line that has the number of points that I want is going to be sitting 3 meters above my topographic surface at those locations. Let's again select my grid. select my line. Okay, so now I'm 3 meters above. And this is going to be my starting point to construct my road. So now I'm going to go into structures, roads. I'm going to create a road from the center line. Okay, so remember I have a 30-meter wide running surface. My cut slope's 3:1. My fill slope can be 6:1. And it's asking me for my cut shell height and my fill shell height. Now this is going to generate, based on this configuration, a cut shell and a fill shell throughout this alignment. It's just asking me how tall I want those surfaces to be. So really, you just have to pick a shell height that you're sure is going to intercept or intersect your topographic surface. So when it clips it, it's clipped properly. So I'm going to go 25 meters. You know, it's sitting 3 meters above the surface. And then you want to make sure you check merge into grid, because that's going to create a dynamic road model. By dynamic road model is retroactively, or after the simulation has run and has constructed this road, I can change these input parameters and it's going to dynamically change the grid. It's going to dynamically change the road structure. Also, I'm going to be able to, as I modify the center line, change the road structure. So everything's going to be manipulatable. Okay, so once again, select your grid, select your center line. And then formation here is just going to run for a bit, and it's going to start generating some files based on this alignment to create a road for that center line. So you can see here, straight in the cut shell, the fill shell. Okay, and then you can see here the new merged grid. So let's just take a closer look here once it's done running. Okay, so I'm going to turn off my initial one. I'm just going to turn this off. Okay, so here, it created the cut shell. So 30-meter flat, 3:1, 3:1. Here's my fill shell. Once again, 30 meters flat across, 6:1, 6:1. And it's created this merged grid. It's kind of faint, but you can see that the road is now built in. Okay, if I select the road item here in properties, it's giving me my input parameters. It's also giving me my cut fill volume balance, right? So I can see here I'm not, I'm not within 1%. Based on this design where I just had that center line floating over the topography by 3 meters, I have 327,000 cubes of cut and 1.4 million cubes of fill. So, there's a couple specifications here I'm not respecting. One, the cut fill volume is not balanced. And two, I don't know if everything here is running at no more than 8%. All right, so I'm just going to also emphasize it's creating the cut and fill footprints here, as you can see here. Now, these files are important because they're letting you know exactly where your road's going to be built. The area here you can associate with a stripping volume. Also, you want to check that you're within your corridor. So based on this, this alignment design, we're good here. We do have a lot of room for the most part to construct other items or stockpile material. Okay, so back to our design. Just going to close down the corridor here. Okay, so we have our center line that we used. So what I'm going to do is I'm going to use another function. I load up my original topographic surface. I have the center line that I just used to build my road structure. And I'm going to go and use this function, plotting edit line profile. Now it's under the plotting section, but I think this is a great design tool. So I'm going to select my line. I'm going to select that, original ground surface that I designed off of. And then it's going to bring up this window. Okay, so you can see here, this dashed line is my original topographic surface, and this is my center line. And this might as well be my road design surface. Okay, so it's giving me my point-to-point slopes. So quickly I can check, if I'm respecting that 8%. As well, this is why I had those steps to try to limit the number of points on my line. Because if there were 1,500 points, they would all be visible here, and it just makes it tougher to work with. So I think, given the length of this road, this is a good amount of data. So what you can do here is, if you want, you can right click on the line, you can insert a new point if you'd like. If you select a point itself, it's going to give you some options. Okay, well, it would give you options. But what I like to do here is I like to set the grade specifically. So I can see here I'm starting to trend over 8%. So I'm just going to choose, a couple points here, and then I can set the grade. So I'm going to set this now. I don't want this over 8%, so I'm going to set it to 8%. And you see it's going to start to modify the configuration of the center line. Same thing on the back end here. I'm at 16%, I'm at 11%, I'm at 9%. So I'm just going to select these areas. Once again, I'm going to set the grade now to -8%. You can do this, just dragging the points. It's going to update the slope for you, or you can do it, set it to specific numbers. I find it's faster just to set it to specific numbers. Okay, so as you modify the line, you can hit this button here, and this is going to update your 3D alignment. So here I'm modifying the elevations along my center line. And if I go back here, I'm dynamically changing the road model. I just have to make sure the grid is loaded. So you can see here, my modifications, obviously aren't complete, but, I'm looking at a cut volume now of 762,000 cubes and a fill volume of 225. So you can, play around with the line and balance this while maintaining that 8%. And you don't have to touch those areas that are floating 3 meters above. So you're accomplishing a lot of, design specification adherence simultaneously to make sure everything's right. And this is going to let you know what's it going to take volume-wise to balance this design. Okay, so that's the preliminary one. If I look at the final alignment here, I'm just going to take a look at this, the profile editor. So this is my, final modified one, which was balanced. I'm going to look at that versus the original surface. So you can see here, basically all we had to do is kind of come in flat here, generate some cut material over here, and then that cut material fills in this area and fills in, the 3 meter requirement here. In the end, it balanced out to roughly 2.7 million cubes of cut, 2.7 million cubes of film, 2.6. So, and at no point are we going over 8%. Okay, so I repeat that process. I repeat that process for alignment 2. I repeat that process for alignment 3. I respect those point-to-point slope requirements. And then, you can develop this. So I went from something that was conceptual to at least, some quantities. I can see here the cut plus fill volume. So these are basically, the cut is half of this, the fill is half of this in these situations. And then, excuse me, based on those footprints that I'm generating, the cut footprint, the fill footprint, I can estimate a topsoil volume. So now you know how much work's involved. Obviously, you can measure the length of the road, but I can see now how much work's involved in terms of, how much material am I going to have to move? How much material am I going to have to stockpile? And then make a decision from there. Obviously here, I don't think there's enough benefit given the higher slope restrictions to not go with alignment 1. So I'm going to proceed and plan the rest of this project with alignment 1. Okay. So let's take a look at surface water management. Close this down. So I'm going to go back and I'm going to open my grid that's merged with the alignment 1 road. I'm going to turn that off. Okay, so once again, you can see faintly the road surface merged in. I'm just going to bring back up my corridor. I want to plan with that in mind. And I'm also going to have my cut and fill footprints open. And that's going to let me know, what real estate do I have to work with? Everything has to fit within the corridor. Okay, so surface water. So the first thing you want to do is you want to go to the water menu. Oh, Teams is interfering with me a little bit. Okay, so you go to the water menu, watershed, and you want to create a watershed. And what this is going to do is it's going to take your topographic surface and it's going to hydro reinforce it. It's going to make it so that your topographic surface simulates the flow of water properly. So now you have kind of a separate grid. And I'll show you the flow grid. It looks exactly like a normal grid. Okay, and so you can see this is the flow grid. So it's slightly modified. So you can't use the flow grid to design because it has been modified to simulate the flow of water, but you can use it to generate streams. It's going to tell you where water is going to flow, at what locations, and then you can use the tools from there. Okay, so it's going to generate by default. It's going to generate streams where 10% of your total topographic surface area are feeding into those streams. So depending on the size of the topographic surface you're working with, that can be a lot of streams or very few. So because I have a lot of topography open now, by default, it generated streams here and here. So that wasn't enough. So you can go back in here, and if you want to generate, you can custom generate it. So you can regenerate the stream network. You can enter any number you want. So 10% of the surface area ended up being 47 million square meters. So I set it to 2 million square meters, and I generated streams to this extent. Okay, so let's just put some Atlas shading on this because I want the topography to really stand out. And let's take a look at these streams and how they're going to affect our work. I'm going to go up here in the north first. Okay, so I can see this is my footprint. This is my corridor, and you can see the streams in blue here. Okay, so I'm a little concerned here. The stream does cross into the right-of-way. It doesn't contact the footprint of the road, but looking at the grading, yeah, I can see that as water accumulates here, it's going to flow away from the road. So I'm not really concerned about this, so I'm going to disregard it for now. Okay, now I'm going to come here, and I have more streams coming into my right-of-way. It's contacting the footprint of my road. However, if I take a look at the imagery here, there is this existing ditch structure. I'm going to assume that the stream here is going to kind of circumvent the road, enter into this stream. There's pre-existing infrastructure here to take care of this. So, okay, I'm not going to worry about that one either. Okay, now I'm looking at this one. This one definitely seems like a problem. The water seems to come from the northwest. It's going southeast, given the grading. It's crossing into the corridor. It's contacting the road. It's accumulating by the road, and it's going through the road. Okay, I can't really rationalize not doing something here. So what I'm going to want to do is I want to lay out an intercept ditch. I want to cut off this water, and I'm going to bring it to a water storage area. I'm going to place that all within my right-of-way, but outside of my footprint. So just something that looks like this. There's my ditch, and I'm going to run it to, an excavated sump or, excavated hole that I'm going to place within my right-of-way. Okay, but I need to know information as to how to size this storage area. How much water should I expect? Okay, so to do that, you go back to your water menu, watershed, and here you want to generate the catchment area. Okay, I could do that live right now. So I'm going to generate the catchment outline and the catchment surface. Okay, it's going to ask me to pick a flow grid. So you have to pick your flow grid. Then it's going to ask me, okay, at what point do you want us to generate the catchment area for? You can generate a catchment area for any point along your topographic surface. So just specify a point on a stream because that's really where the water is going to accumulate. So that's what you want to know. So I'm going to pick this point here before it splits. I want to know how much water is going to be coming in. So I'm going to pick that point right there. Okay, then it's just generating the files. You can see the outline. And you can see the surface. I'll just zoom out here. Okay, so for this point right here, all of this area is going to feed into there. And it's going to tell me right here in the output how much area that is. So 5.224 million square meters is going to flow into this stream, come into the right-of-way. Okay, so 4.224 meters. I'm going to do some research into precipitation in this area. And I'm going to say, okay, I can expect within a 24-hour period, 30 millimeters of rain. Just got to do a little flip. Okay, so basic math here. My catchment area, time the meters of precipitation per day is going to be the volume of water I can expect that I'll need to manage. So I'm just trying to get through a 24-hour storm event here. So 5.224 square meters, 0.03 meters of rain that day. I need a sump that can contain 157,000 cubes. Okay, plus I want some freeboard. So I want 157,000 cubes plus. Okay, so now I can use more dynamic structure tools within Formation to design this sump to contain exactly that amount, or exactly the amount I need. Okay, so let's just turn off some layers here. I'm gonna go and turn on my alignment 1 grid with the road built in. I'm going to turn off my flow grid and turn off my streams. Okay. So I want to design a sump right there. I'm not sure if it's going to work in terms of sizing, but I know I need to fit it within here and I need to cut off that stream. So, it kind of has to be around here. Okay, so I'm going to go structures, excavations, excavation from crest. So this is convenient because, I have limited space. So I don't want the excavation to go beyond this line. And then here you can just set, I want 2:1. I want to go down 20 meters. And once again, I'm creating a dynamic model. I want to merge it into the grid. Okay, so I'm going to come here. I'm going to select my grid with my road merged in. I'm going to select the crest of my excavation. And it's just going to come down at 2:1 and create a flat bottom excavation. You can see it's creating more tools or more layers. Should take like a few more seconds. Okay, so let's turn off the road with the grid merged in. I don't need it anymore. So now I have a new structure. Okay, and let's go down to the excavation. Okay, so once again, properties telling me what did I input here? I went down 20 meters at 2:1, and that resulted in 276,000 cubes of excavation. And it's telling me my footprint is 37,000 square meters. Okay, in terms of the files created, let's just take a look at these. So created the excavation shell, 2:1, going down 20. It created the break lines associated with that. The footprint, the toe, and then of course, the merged grid here with the sump in it. Okay, so I know this is a 276,000 cube excavation, but that doesn't really tell me how much capacity I have. So I'm going to pair my dynamic sump model with a dynamic pond model. So I'm going to come here, structures, pond, create a pond surface. Put this pond in at 1,585 meters in elevation. Just try to pick an elevation that, you know is going to be somewhat contained. Just kind of take a guess. It's going to ask me what grid I want to use. I want to use this grid with the sump for sure. And then I want to put my pond right there. Okay, so now I can see my pond. It's just going to take a few more seconds. It's generating the pond surface, the pond outline, and there once again, another dynamic model. Okay, now this is important because now it's telling me how much water I actually have in there. So based on an elevation of 1,585, I have 99,000 roughly cubes of water. Okay, so I need to store 156. I want about a meter of freeboard. Formation just told me this is 37,000 square meters. So a meter of freeboard is probably around 35,000. Okay, so 155 plus 35. I want about 190,000 cubes of capacity to withstand this storm event and have a little freeboard. So you can do a couple things here. One is you always have the option of increasing or modifying the crest line that you use to build the excavation. So if I expand this crest line, it's going to dynamically expand this sump and increase its capacity. So I could do that, but I want to go fast here. So I'm going to start by establishing, how much water can I put in here as it exists? So I'm going to go 1589. If I increase by 4 meters, what happens to my pond? Oh, okay. It's letting me know. If you go to 1589, it is going to spill. It is going to overtop. You don't have capacity to that elevation. Okay, what about 1588? Okay, so that works. And get to 1588. That's probably the max. Maybe I can, get 1588.123, but, we don't need to design it to that extent right now. And that's going to give me 162,000 cubes of capacity. All right, that's not enough. I want 190. What's the best way of doing this? I can't go up in terms of my water surface, but I can go down in terms of my excavation. So if I make this, let's say, 22 meters deep now, it's increasing the excavation to 294,000 cubes. Okay, so I'm going to have to excavate another 20,000 cubes. Now I'm at 181. All right, go back here. Let's take another, let's go 23.5. Okay, so I need to excavate 304,000, but now I'm at 190.995 cubes. Okay, so now I know exactly, based on this footprint, how deep I have to go. Once again, otherwise, you can just modify the crest line itself by just going to polyline, edit line. You can select the line, and then you can start moving these points around. See, once again here, I've probably draped this line, so I have too many points. So I would thin it, and then I would just start moving these points around and increase the footprint instead of going down. All right. Okay, so now I have my sump. I have it located. Now I just need a ditch. So for the ditch, I'm going to repeat a very similar process to what I did for the road. I'm going to drape it. But this time I'm going to drape it a meter low because I want at least a meter in depth in terms of my ditch bottom. And I also want to make sure that I have at least 1% slope. So I'm going to come here and I'm going to utilize the plotting, edit line profile tool again. Actually, let's use another line. Okay, so this is kind of the final ditch line that we developed here. So what I did, I start out draping in a meter low. So I'm getting at least a meter in depth, and I know that throughout. And then I'm just going through here. And because it's a meter low, it's not always going to be at 1% grade. So I just modify it once again to achieve 1% grade. And so now you have a ditch line that is sloping at least 1% and at least 1 meter below. Oftentimes it ends up being more than a meter below just so you can maintain that 1% grade. And then from there, you can just go here. Once again, structures, excavation, create ditch from center line. And then once again, you can create a dynamic model with your ditching. And it's going to tell you how much you need to excavate. Okay, so we've cut off the water. We have a ditch in place. Okay, I'll just turn on the ditch surface here. Okay, and you can see them here. You can see the ditch here into the sump designed for that rainfall event based on this catchment area at this specific location. Okay, so we have our road design. We have, some surface water management infrastructure in place. Now we want to talk about stockpiles. Okay, so to begin, I just excavated 300,000 cubes of material here to build this sump. I'm going to assume at the end of this project, I'm just going to backfill this sump with the material I excavated. And, that'll be it. I'm not going to use this material to build the road. I'm just going to backfill this. I can't leave it like this. And also, based on the cut footprint, the fill footprint, we're going to be generating, 267,000 cubes of topsoil. Now, I'd love to direct place all of that, but that's probably not going to be possible. So I'm going to just assume I'm stockpiling all of this topsoil. I'm going to stockpile half of it in the south, half of it in the north, and then I'm going to use that to reload my slopes at the end for stability at the end of the project. Okay, so I want to build some stockpiles. I want to build them exactly where I want them within a specific footprint to a specific capacity. Okay, well, if I'm going to excavate this sump, I want to put a stockpile right here. I'm just going to come in here with an excavator and just try to dump this back in. I don't know if that's possible, but, I'm going to put the stockpile beside, the hole I'm going to fill. Okay, so more dynamic models, structures, dumps, dump from footprint. In this situation, very convenient. Footprint's my issue. I have to build it within a very tight area between the road and the corridor. So, I don't want to mess around too much. So I can just build it exactly within here. Call this dump. Okay, I'm going to go crest elevation. Let's say 1611. So, just try to guess what elevation it can get built to. You can always adjust this afterwards. I'm going to go up at 2-to-1. I think I can stack this at 2-to-1. Select my surface, select my footprint. Okay. Well, that was unforeseen. No, live webinars. So I'm just going to reload. Might take a couple minutes. So I likely had too many layers open. And it didn't like that. My apologies. I guess I couldn't, I should have proceeded with a little more caution there. Okay, so stockpiles. Okay, so I'm going to open my topographic surface with my road, with my sump, with my ditch. See it here. I'm going to open my footprint for one of my stockpiles. And let's try this again. Go 1611, 2-to-1, select my grid, select my footprint. And once again, creating a dynamic model here. Take a look at some of the files here, creates the shell. You can see it's nicely textured here. The crest of the dump at 1610, different break lines, the toe, and the merge grid with it incorporated. Okay, now if I take a look here, lucky guess here, but I'm going to be stockpiling exactly 301,000 cubes of material. And I can repeat this process and create more stockpiles here. Now I have, 167,000 cube topsoil stockpile over here, another stockpile over here. And if I turn my alignment files back on, I can see, I'm still within the corridor, but outside of the footprint. So I have my road built, I have my stockpiles, I have my intercept ditch and sump. Let me just turn on the pond here. I have that all fitting in within my 500 meter right away. You can see, you know, 500 meters seems like a lot of space, but here it's getting kind of tight. Obviously, you want to leave some room here. If you want to take quick measurements, you just go to info, distance measurement. And I can see, you know, I'm going to have 40 meters here, roughly, of space between my stockpile and my toe. There may or may not be enough room depending on the size of your equipment. Okay, so we've got all our infrastructure in. You know, we have a balanced design. It's respecting the specifications we laid out. Okay, but what happens if you're dealing with a design that, you know, it can look like this? What happens if it starts to look like this? You know, a lot of detail. You know, suddenly you have a surface course, a binder course, shoulder zones, you know, permeability liner. You know, this isn't a real design. It's meant to mimic a real design. I kind of just made it up. So, you know, if anybody's out there and has experience designing roads, please don't look at this too carefully. But, you know, the idea is it's going to resemble something like this. There's going to be a lot of information, and you might want to start planning with this in the beginning in terms of, you know, wanting to really monitor these quantities. So really looking at this here, you know, everything below this permeability liner is really the earthworks portion, right? This is dirt. Above here isn't dirt. So really, these areas above the permeability liner, these are always going to have to be placed. And really, here is going to depend on you know, the marriage of your topography with your design and how it works out from a cut fill perspective. Okay, so let's say this is what you want to work with. You know, those weren't really options in our dynamic model tools. So what we do, we go into Muk and we use this zonation tool. And this is where we can build that kind of design and overlay it onto an alignment. So you go into the graphical zones editor, okay? And it's designed largely like offsetting lines, except you're offsetting points. So you can see here, you're starting at node 1, and then you can start adding nodes. So I'm going to click on node 0, and it's asking me, how do you want to offset it? I like dx, dy, simplest, just difference in distance in x, difference in distance in y. Okay, so I want to build that crown. Now these are not exact measurements, but I know I'm going out at, you know, 8.5 meters out, and I'm going down, you know, 0.17 meters. And I think that roughly reproduces like 2%. Okay, now it's going to add another point here. So now I have a point over here. Okay, but I want to reconstitute that top layer crown. Okay, I come here. Now I'm going to go dx dy again. I'm going in the other direction now. So minus 8.5 meters, minus 0.17. Okay, and now I'm just slowly building all these nodes. Okay, I'm going to come back here to 1. I'm going to go down at 3 to 1 now. 3 to 1, I want to kind of build a ditch. So dx dy. Okay, so I want to go east. So I'm still going east. I'm going to go down at 3 to 1. So I'm going out 3 meters, down 1 meter, you know, so on and so forth. Here, if I look at these offset points, you know, I can see the relationship between them, and I can even change these. So these are dynamic. Okay, I don't want to go down 1 meter anymore. I want to go down 2 meters. So you can see it's going to change its position. So you can reconstitute essentially all of these nodes. This is what you're looking to do. You're looking to place all of these. So depending on your design, you lay out all these nodes. It's going to open an existing model here. So you can see here, you know, I've kind of recreated it. I've laid out all these nodes. Okay, now I want to start adding these components in, you know, the different material types. So that's really easy as well. I go here, create, and I want to draw a layer. Okay, I'm going to call this, you know, top layer. And I'm going to come here. I'm just going to draw it in. So you just join the nodes that correspond to that layer. Very easy. Okay, so that's one layer. Hit spacebar when you're done. And you can see it's been added here. And then I'm going to open the final one here. And you can see here, you know, essentially what we've done is we've recreated this into here exactly. And you even have, the permeability liner and then all the zones. Okay, so I'm going to come back here. I'm going to shut these down. Okay, so I'm going to open up my alignment 1 again. If I can find it. All right, so here I have my alignment. I can go to zonation now. I can go build shells. I choose this one. I'm going to pick my alignment. And now it's going to create all those offset lines. As well, if I want, I can take the zonation models. Let's just close those down. So I'm going to take my zonation model, and I can drag and drop it and place it onto here. And now it's going to rebuild all those nodes. It's going to start offsetting the line based on where my alignment is, and it's going to build all those layers. So you can see all those layers are built here. So, some of them are pretty thin, but everything's in here. Okay, and then I can start using this model versus my topographic surface. Just going to open my topography here. And now you can see you have a model. Okay, now you'll notice this model worked in a fill situation, but it didn't work in a cut situation, right? It just took all those solids and superimposed it onto the topography, but it didn't take into account when it dips down under, it gets obstructed by the topography. Okay, so to work around this, what I do is okay, so this is the final model. This is how I want it to look in the end, but I need something to take into account cut situations. So I'm going to create another zonation model, but this time just for cut, right? So I know this is my Earthworks model. So this portion here above the permeability liner, you're always going to need to place that. But in cut situations, I'm going to have to excavate. And I'm going to excavate in this configuration, right? Down to the permeability liner, and then I'm going to add this back in, right? So in cut situations, really, it's going to look like this. First, I'm going to cut down like this, down to this liner, and then I'm going to place this back on. Okay, so to do that in Muk quickly, what I do is, let's just close down some layers here. Okay, also, one thing to take into account, your final road alignment is going to be lower than this cut model. So you're going to just need to take your alignment, drop it a little, build this shell, modify your topographic surface, and then put that back in. I'll just show that to you now. Okay, so I'm going to go into zonation model here. Have an offset. I have my alignment. It's a little lower to take into account that this is now the cut configuration. I'm going to take my zonation model before the cut that I've made. Okay, and it's going to generate these offset lines. So you can see here, it just generated my lines based off that configuration to create a cut surface. And then I can quickly triangulate this using surface, triangulate between lines. I'll call this cut surface. Then I just come in here, create a shell based on these lines. Make sure I get them all. Okay, now I have my cut shell. I'm going to reload my topography here. Now I'm going to merge this excavation into my topographic surface. So grid, merge excavation into grid. So this is going to take the lower between my topography and this excavation cut surface. So I pick my grid, pick this. Now it's modified my topographic surface to incorporate where I'm going to need to cut. Now I can come back here. Oops. Use my, alignment 1 polyline. And now when I open up these layers, it's going to be built comprehensively throughout onto the topographic surface. And then you can do different things. You can go in here. You can start running zone volumes. You can see that here. So based on, 1 meter increments, it's telling you for every type of material type, how much volume you can expect. As well, when I merged my surface, my cut surface into my topography, it's telling me, I removed 4.6 million cubes to construct this. Okay, I see we're at time now. I'd like to thank you for joining me. If you have any questions, please feel free to forward them, and have a nice day.
If anyone has any questions that you want to ask now, you're welcome to.
Sure.
Yeah.
Okay, I'm just going to look in the chat here at the Q&A. Okay, Sam has referenced PDF documents a couple of times. To confirm, he's referring to the help within Muk, correct? So right now, we have written and created PDF documents that are specific to this scenario. They're very detailed. So everything, that I've gone over today, is in the PDF documents in great detail. So, if there's anything you have questions on, or, I went over too quickly or maybe not thoroughly enough, you just refer to the documents. We're going to make them available shortly, along with all these files. So you can just kind of follow along with an instruction manual. Okay, does anybody have any questions? All right. Well, if anybody thinks of something, feel free to reach out in an email. Yeah, and if there's any type of specific webinars or instructional videos that you guys would like to see, also please feel free and let us know. There's obviously a lot of different things you can do with the software. So, it's always good to get customer feedback in terms of where to focus our energy. All right, so I see no more questions. So thank you, and have a nice day. Unless there's anything else, Carlo.
No, I think we're good.
All right. Thank you, everybody. Bye.